Okay, let's continue. This is still 13.1. I ran out of time last time, but now I'll finish up the actual applications. Example 6, using production and geological data, the management of an oil company estimates that oil will be pumped from a producing field at a rate given by R of t equals 100 over t plus 10 on the domain 0 to 15. R of t is the rate of production in thousands of barrels per year, t years after pumping begins. Find the area between the graph of R and the t-axis, y equals 0, over the interval 5 to 10, and interpret the results. So we're going to handle this just like we handled all the other problems, right? All the other problems before, which is above, graphing, finding the area between two functions, right? Okay, so first thing we want to do is sketch both functions. All right, and I have the calculator here because these ones might be heavy on the calculator work. The last ones, I believe you could do because we've been doing them for the past 2 or 3 lessons now. So you got this. But for now, for these ones, I'll show you the calculator work involved. So the first thing we're going to do is make our XY charts, right? So here we go. So for A, for R of t equals 100 over t plus 10 plus 10, you'll make your XY chart, or even better, your T Y chart, because this is all in terms of T. If you want to change it to X, change it to X, because that's how I'm going to have to type it in the calculator, is as X. All right. So here I make my chart. We're given the numbers on the interval 5 to 10, right? 5 to 10. So I'll do 5, 6, 7, 8, 9, 10. Okay, now let's type this in the calculator. So I'm going to have table, clear, fraction, 100 over x plus 10. We have to type it in terms of x, plus 10. So there's the function, 100 over x plus 10 plus 10. Hit enter, make sure you're on ask. And now let's type in the values. 5 will give me 50 over 3. Well, if I don't want that, change that to decimal, 16.67. Oops. So 16.67. Just waiting for the computer to catch up. Ugh. All right. Then we'll type in 6. And we'll get 65 over 4, or 16.25. Type in 7, let's do that. I'll do 7, 8, 9, just to get this going. 270 over 17, or 15.88. Go down to 8. 140 over 9, or 15.56. Go down to 9, 15.26. And go type in 10, 15. Hey, one nice number. 15. Okay. There's the XY chart, or the TY chart for R of t. And now for G of x, well, looking at the problem, where is it? Right here. Y equals 0 is going to be my G of x. That's going to be my G of x. So down below, graphing G of x. I'm not sorry, G of x, G of t, since this is in terms of t. G of t equal to 0. Make your TY chart, pick the same values, 5, 6, 7, 8, 9, 10. And no matter what we pick, y is always going to be 0, 0, 0, 0, 0, 0. Okay, let's make our graph appropriate. We're using 5 to 10. So let me write my graph. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The largest I go up to is 16.67. So let's go by threes. I think we can go by threes. Yeah, we can go by threes. Why not? It doesn't have to be perfect. Okay. So 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 18. Okay. And let's plot. So for the blue one, I am at 5 and 16.67. So 5 and basically 17, I'll put it right there. And then for 6, 16.25, just go a little lower. 7, 15.88. I'll put that like right there. Hang on, I'll zoom in when I get there. 8, 15.56. Oh, yeah, I guess I should have done these dots a little better. Let's see. Okay. So we'll just have something like this. There we go. Now let me zoom in and show you what I did. There you go. And our graph should look something like this. Just like that. And then for g of x equals 0, well, you have 0, 0, 0, 0, 0, 0, and you just have a line that looks like this. Okay, and once again, we are finding the area between these two graphs. So here's r of t, and here is my g of t. Which means that r of t is above g of t, so this would be a case 1. This would be case 1. So let's go back. So there's that. This would be case 1. So I'll write that here. So B, this is a case 1, which means we'll use the integral from A to B of r of t minus g of t dt. And again, if the t's are too confusing, just change all your t's to x's. They're the exact same thing, which means we can move on to step C. Let's find the antiderivative. So we're going to go from the integral of 5 to 10. the integral of 5 to 10 of r of t, which is 100 over t plus 10 plus 10 minus g of t, which is 0 dt. Okay, so we definitely have some cleaning up to do. And I think I need to write smaller. We'll first get the integral from 5 to 10 of 100 over t plus 10 plus 10 dt. Okay, got to do some more rewriting here. So I'm going to split this into two integrals. And the reason I'm doing this is because we have a new antiderivative formula above, if you saw that. Where right there above says the integral of 1 over x plus a dx is the same as the natural log of the absolute value of x plus a. So that's the new one we're going to use. But in order to use it, I need you to see it, so I'm going to rewrite. So I'm going to have this as the integral from 5 to 10 of, I don't need parentheses, of 100 over t plus 10 dt plus the integral from 5 to 10 of 10 dt. All right, another rewrite, and then we can do it. All right. So now we will get, what I'm going to do for this one is on the first integral, I'm going to pull out that 100 to the outside. That's going to the outside of the integral. So this means I will have 100 times the integral from 5 to 10 of 1 over t plus 10 dt plus the integral from 5 to 10 of 10 dt. Okay, we are now ready because, I'll just jump on the other paper, I'll erase it though, because this part uses the new antiderivative formula. The integral of 1 over x plus a becomes the natural log of x plus a. So that's what we're going to use here. So that means that all of this becomes, oops, (100) times the natural log of the absolute value of t plus 10 plus, what's the antiderivative of 10 by itself? That is 10t. And now we are evaluating all of this from 5 to 10. Now let's see what we get. So let me type this in the calculator. Table, natural log, 100 times the natural log of x plus 10 plus 10x. Enter, 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 enter. If I type in 10, I get 399.57. Minus. If I plug in 5, 320.81. $320.81. Which means that all of this, let's see, quit 399.57 minus 320.81, enter, is 78.76. 78.76. Okay. Now, what's the easiest way to type it in your calculator? Well, I'll show you. So this is what you're going to type in the calculator. So we're going to have second. Oh, I need to switch to the other one. Oops. There we go. Second integral 5 to 10 of fraction 100 over x plus 10 plus 10. And now, to make our lives a lot easier, I hit enter, and guess what we're gonna get? 78.76. Or maybe even here is 78.77, and I'll trust this one more, 78.77. So that's what we can have here, 78.77. Okay, so there's our answer, and then or 78.77. Okay, but now what was this question asking? It says, interpret your results. So we want to know R of t is the, find the area between the graph of R over the interval 5 to 10 and interpret the results. So what we want to say is that from 5 to 10 years, we are going to produce 78.76 thousand barrels. So D, let's interpret our answer. So right here, I'll do it right underneath. We're going to do D. So interpret. So remember that we are in thousands of barrels. So this means that we take our 78.77 or 76 from my calculator on the left. I'm going to do 77. 78.77. Multiply it by 1,000. And this is going to give me 78,768.21. I mean, of course, if I rounded, like if I did the 78.77 times 1,000, we'd have 78,777. So I could say or 78,770, right? Okay, so what this means is that between 5 to 10 years, we will create 78,770 barrels of what? Oil. And that's what we're looking for. There we go. There it is. That's how we do that. All right. See, isn't it good I split this up into 2 videos? That was a lot by itself. Okay. Another one. All right. An amusement company maintains records for each video game it installs in an arcade. Suppose that C of T and R of T represent the total accumulated costs and revenues in thousands of dollars, T years, after a particular game has been installed. There we go with the T again. So if C prime of T is 2 and R prime of T is e to the 9e to the negative 0.3 T, find the area between the graphs of C prime and R prime over the interval on the t-axis from 0 to the useful life of the game and interpret the results. Okay, so first thing we want to do is find the missing part to the given interval. So to find the missing part to the given interval, because we want to know how many years was this useful, so it can't be 0 to infinity. We actually had to find an endpoint for this. So to find the endpoint for this time period, we're going to take R prime of T, set it equal to C prime of T, and solve for T. So wherever the cost and the revenue meet, this is where the game broke even on its revenue and cost, and we're probably going to get a new game, right? Because nobody's playing it anymore. All right, so that's what we're going to do first. So A, find the missing part of the interval 0 to B. So our job is to solve for B. Okay. So let's do it. So A, find the interval 0 to B. That's what we're going to do here. Find the interval 0 to B. And the way we do that is we are taking R prime of T, setting it equal to C prime of T. So R prime is 9e to the negative 0.3 T, and we're setting it equal to C prime of T, which is 2. So our job here is to solve for this T. That's our goal. We're going to solve for that T. So to do so, we need to get E by itself. So the first thing we're going to do is divide that 9 off. Divide by 9. Then we get e to the negative 0.3 T equal to 2/9. Okay. Now the question is, how do we get that T down? Well, remember what you know about logarithms, which is probably nothing anymore, right? Okay, so remember with logs, let's just say I have the natural log of x equal to, let's say the natural log of x equal to some number y. There we go, just to work. The natural log of x equal to y. Come on, computer, keep up with me. Well, with that being said, we know that for natural logs, let me zoom in a bit for you. You're going to need to see this because I'm going to erase it. All right. So for natural logs, we know that the base of a natural log is e. And what we also know about logs is that we can convert logs into exponentials. So all I have to do for that is take this e and raise it to this y. So this becomes e to the y equal to the inside of this log, x. So you get e to the y equals x. Okay. So we know you can go from log to exponential, but now we must remember that we can also go from exponential to logarithm. So this is what we're going to use. So this means that if I go from exponential to logarithm, one thing to remember is that the base of the exponential function is the base of the logarithm. So this becomes the base. So this means when I convert this back to a natural log, this becomes natural log base e of, and this means that this number, x, will go inside the log. So you get natural log base e of x equal to, and what this means is that this y value is going to go outside. So you get natural log base e of x equal to y. Now, one last thing is that we know that e is the base of the natural log. So I write my answer as natural log of x equal to y. And look, we're right back at the beginning. Okay, so that's what we're going to do here on the left side. So I'll leave this up for now, but like I said, I'm going to erase it so it doesn't take up space. And this is stuff you should know already. All right, so with that being said, if I'm going to rearrange this from exponential to logarithm, this will become natural log base e. The 2/9 is coming inside. And the exponent of negative 0.3t is going outside. Look at that. Now again, I'm going to rewrite it because we don't need that base of e there. Natural log 2/9 equals negative 0.3t. And now to solve for t, just divide by negative 0.3. Negative 0.3. Now I will do that in the calculator over here. I will do fraction button, where are you? Natural log of 2 divide 9 over negative 0.3. Enter. we get 5.01, which I think we can just leave as 5, I hope, because this is in terms of years. So we get that 5 equals t, which means we have found our b value. This means that the interval is going to be from 0 years to 5 years. This was the b value. Okay, there you go. Breathe it in, take a picture, write it down, pause the video. I'm erasing everything on the right side. There we go. Okay, that was step A. We found the interval 0 to 5. 5 was our b value, okay? All right, so step B, sketch the graphs, okay? Sketch the graphs. So say step B, we are sketching, which means we need to graph r prime of t and c prime of t. So my first graph is for r prime of t, and that is given as 9e to the negative 0.3 t. Make your ty chart, or like I said, replace them all with x's, whatever you like. So here's my ty chart. And we know what numbers to pick. Our new interval is from 0 to 5. So that's what we're going to do. 0, 1, 2, 3, 4, 5. Okay, typing that in your calculator. Well, look on the left side over here. Table, add function, right? You either have y equals or you have f of x equals, whichever you're using. So I'm typing in 9e to the negative 0.3 x. In the calculator, it has to be x. 9e to the negative 0.3 x. Enter. Don't care about g of x here. Well, later we will. Enter, enter, enter. And now let's type in. If I type in 0, I get 9. If I type in 1, I get 6.67. 2, 4.94. Go back up. 3, 4, 5. 3 is 3.66. 4 is 2.71. 5 is 2.01. 2.01. Okay. Now let's do c prime of t. C prime of t is 2, right? So for my xy chart or my ty chart, this one's going to be the easiest because from 0, 1, 2, 3, 4, 5, no matter what value of t I plug in, the y value is always going to be 2, 2, 2, 2, 2, 2. Not bad. Okay, now let's graph. So we're going from 0 to 5. I can definitely stretch this graph out. So 0, 1, 2, 3, 4, 5. And then for my y values, the highest I go is 9. So these are going to stay the same then. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and let's plot. All right, so I'll plot the numbers first and then I'll zoom in. So 0, 9 for my first function. 0, 9. There we go. And then 1 and 6.67, so probably right around there. 2 and 4.94. 2 and 4.94, basically 5. 3 and 3.66, right here. 4 and 2.71, right around there. And 5 and 2.01. So basically at 2. Okay. So this is what we look like so far. So your r prime of t looks like this. There's r prime of t. Maybe curvier. Okay. And then we want c prime of t, which is just 2, 2, 2, 2, 2. So 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. So this is what c prime of t looks like. Bam. And what we want is the area between these two functions. So that's r prime of t. And this is c prime of t. Okay. So now, come back here. We have sketched what case works. Well, r prime is over c prime. So again, this is case 1. So that can probably be c then. I can fit that right here. C. This is case 1, which means again, we'll have the integral from a to b, but this time we're going to put it in terms of what we're using. R prime of t minus c prime of t dt. All right, let's get started then, down below. Let's hope it doesn't get messy, okay? All right, so now this is step D. Let's find the antiderivative. So set up the integral. The integral from, what are we on? 0 to 5. From 0 to 5 of r prime of t. And remember, r prime of t is 9e to the negative 0.3 t minus c prime of t, which is 2. dt. Let's get a little close up there for you. Okay, this one's not going to be that ugly. So we are ready for the antiderivative. Remember that this part, the e to the negative 0.3t, remember that if you have the integral of e to the ax dx or dt, whatever, that the antiderivative is 1 over a e to the ax. So 1 over a e to the ax. So that's what we're going to use here. Okay, so you get 9 times, now what we're doing is the antiderivative of that e, so it's going to be 1 over negative 0.3 e to the negative 0.3 t. There's that first part. Minus, well, that's just 2t. And we will evaluate from 0 to 5. Okay. Cleanup. All I'm going to do here is do the 9 over negative 0.3, or 9 divided negative 0.3. That's negative 30. So we get negative 30 e to the negative 0.3t minus 2t, still evaluated from 0 to 5. Okay, let's crunch away, because we're there, guys. We are there. So I'll do that table, add, clear this out. I get negative 30 e to the negative 0.3x minus 2x. Make sure it's all there. Enter, enter. And I type in 5. I get negative 16.69 minus, I type in 0, I get negative 30. Okay, right there, negative 16.69 minus negative 30 gives me a positive 13.31. Okay, what does it all mean? What were we looking for? That's the area between the graphs. So an amusement company maintains records for each video game it installs in an arcade. Suppose that C of t and R of t represent the total accumulated costs and revenues in thousands of dollars t years after a particular game has been installed. Okay, so find the area between the graphs of C prime and R prime over the interval on the t-axis from 0 to the useful life of the game and interpret the results. Okay, so again, we're going to take our answer and multiply it by 1,000. So this is going to be E. So we take our answer of 13.31 multiplied by 1,000, and we get $13,310. So what this means is that over the lifetime of this game, from 0 to 5 years, this game has made this amusement company $13,000, right? So in the 5 years, it made the amusement company $13,000. So interpret So money made from 0 to 5 years. All right, there you go. So that's the money that machine made them from 0 to 5 years. All right, not bad. Okay. Oh yeah, I didn't check our work. Let's see. Let's do it. Second integral 0 to 5 of 9e to the negative 0.3x minus 2. $13.31. Boom, 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 boom. So yes. So over that. So again, the interpret is, I guess they want to know how much money it made. Because if you look at the graph, R prime and C prime are intersecting, and where they intersect is where it breaks even. So it made them 13 grand in those 5 years, and now they're going to get rid of it because now they're not making any money. It's outdated, so now they get to update to a new game. Okay, perfect. Ooh, buddy. All right. Okay. More definition, okay? All right. So now we get into the actual Lorenz curve, which is all about absolute equality and inequality, and it's about income. It's about is income being equally distributed and stuff like that. So one method used by economists to study the distribution of income in a society is based on the Lorenz curve. The Lorenz curve is found by using regression analysis, a technique for fitting a function to a data set over a given interval. X represents families at or above income level, and Y represents the cumulative percentage of total family income received. All right. So you see these graphs down here. All right. So absolute equality of income would occur if the area between the Lorenz curve and the line y equals x were 0. The closer a Lorenz curve is to this line, the more equitable the income distribution is among the income recipients. Okay, so the closer we are to the line y equals x, this means the more that income is being equally distributed, right? So our job, our goal is to hit this line, right? We want to hit the line y equals x. But that's never going to happen, because if we hit that line of absolute equality, this means that the person next to you makes the same much money as you, the person in another state makes the same money as you, the person in the whole, everybody in the whole city is making the same amount of money. Is that ever going to happen? No, never, right? But then let's say that the actual triangle fills up, right? Let's say that all of this fills up. This means that if the Lorenz curve fills out the whole triangle, this means if it reaches 1/2, this means that's the whole area of the triangle. This means that income would be in the hands of one family and the rest would have none. Now that seems more like us, right? So let's say that the area filled out to the whole triangle on the Lorenz curve. This means that none of us are making money anymore and one family is making all the money. So this means that income is being definitely distributed unequally. Okay, so we don't want that to happen. So it's best, I mean, if we stay within the middle, somewhere around there, right? If we stay within the middle. So we'll never hit that line of equality, but as long as we stay somewhere between half, we should be good. Okay, so to represent the Lorenz curve, we use something called the Gini Index. Gini, yeah, Gini, 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 Gini. All right, I'm going crazy. We'll just say Gini Index. All right. So to find the Gini Index of income concentration, we use this formula right here. 2 times the integral from 0 to 1 of x minus f of x dx. The Gini index is always a number between 0 and 1, and a Gini index of 0 indicates absolute equality. This means that we're touching the line y equals x, and a Gini index of 1 indicates absolute inequality. This means that somebody's making all the money and we're not getting any. Okay, so the Gini index is used to compare income distributions at various points in time between different groups of people, before and after taxes are paid, between different countries, and so on. Okay, so with that being said, we come to our very last problem. Whoop, whoop, whoop. All right, so this means that, for example 8, the Lorenz curve for the distribution of income in a certain country in 2013 is given by f of x equals x to the 2.6. All right, there we go. Economists predict that the Lorenz curve for the country in the year 2025 will be given by g of x equals x to the 1.8. Find the Gini index of income concentration for each curve and interpret the results. Okay, so we want to know what the income distribution in 2013 is or was, and we want to know what the income distribution could be in 2025. So we will use the Gini index on both of these. So let's go ahead and set this up. So let's do it for A. Okay, we're going to do it for A. For 2013, right? So this is for A. For 2013. All right. So we'll say our Gini index is equal to 2 times the integral from 0 to 1 of x minus f of x. So let me see. 2 times 0 to 1 of x minus f of x dx. Okay, so for 2013, our function's x to the 2.6. So we get x minus x to the 2.6 dx. X minus x to the 2.6 dx. Okay. And now, well, let's find the antiderivative. This is all set up already. So all we have to do next is say, well, two times, bracket for neatness, and we're going to start with the antiderivative of x, which we know that one all too well. X squared over 2 minus the antiderivative of x to the 2.6. Well, that's just power rule. You get x to the 3.6 over 3.6. And we will evaluate this from 0 to 1. Of course, let's clean it up a bit. Let's distribute that 2. If I distribute that 2, you'll get x squared minus, and what is 2 over 3.6? Ooh, 5 9ths. Okay, or you can just leave it as 2 over 3.6 if you want. So I'll say 2 over 3.6 x to the 3.6 from 0 to 1. Okay, let's calculate. Over here on my calculator table, add clear x squared minus fraction 2/3.6 x raised to the 3.6. Enter, enter, enter. Type in 1, and I get 0.444. 0.44 minus, type in 0, I get 0. So we get that in 2013, they had a Gini Index of 0.44. 0.44. Okay, we can't compare this until we get the answer for B. So in 2013, their Gini Index was 0.44. So now let's go look for B. So B, this is for 2025. So their Gini Index is going to be 2 times the integral from 0 to 1 of x minus, and the Gini Index they're giving us for 2025 is x to the 1.8. So x minus x to the 1.8 dx. Okay. Well, we're ready for the antiderivative, which means that we'll get 2 times, and this is just like the other one, antiderivative of x, x squared over 2, minus power rule, x to the 2.8 over 2.8, and evaluate this from 0 to 1. Okay. Clean up, distribute the 2, you'll get x squared minus, and again, do we have nice numbers or not? 2 over 2.8. No, or that's 5/7, whatever. I'll leave it as 2 over 2.8, x to the 2.8, and evaluate from 0 to 1. Okay, so table, and that's x squared minus 2 over 2.8 x to the 2.8. Enter, 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 enter. Type in 1, which is there already. You get 0.29. Minus, type in 0, you get 0. So the Gini Index for 2025 will be 0.29. Okay, so this means that, well, we say that, looking at above, a Gini Index of 0 indicates absolute equality. A Gini Index of 1 indicates absolute inequality. So this means that we're looking at the distribution of income in a certain country. This means that in 2013, they had 0.44, which wasn't bad. But now in 2025, it's predicted to have an index of 0.29. So this means that it is predicted that in 2025, their income will be more, their income will be distributed more equally, right? So that's what we can say. In 2025, income is more equal. Income is equally distributed more than 2013. How's that? Boom. There you go. Oh yeah, I didn't check our work on the actual calculator. So one moment, if you want to watch. So for 2013, I would type this in as 2 second integral 0 to 1 of x minus x to the 2.6. Enter. 0.44. Genius, right? And then again, 2 second integral 0 to 1 for 2025. So you get x minus x to the 1.8, 0.29. So we are good. Woo-woo. All right. So that is it. That finishes 13.1. Oof. See, that in itself took about an hour. Okay. So that is it. That finishes. So now you can do the rest of the homework. You're welcome.